Ramakalyani, please take over.
Namaste. Sharada Sharadamboja Vadana Vadanambuje Sarvada Sarvada Smakam Sannadim Kriyat. Shri Gurubhyo Namaha Namasadase. I just share my screen.
Madam, please adjust your distance to it so that your full picture will come on. Now it's okay. Okay, madam. Thank you.
PPT, see? You are able to see the PPT?
Yeah.
I am Dr. V. Ramakalyani from Chennai. I have done my PhD in Sanskrit from University of Madras. I have taught mathematics and Sanskrit for several years, and now I am doing some research projects for different research institutions like the Kupashami Sastha Research Institute, K.V. Sharma Research Foundation at Chennai, and National Mission for Manuscript and Sanskrit Promotion Foundation, New Delhi. Now I am a project consultant for HOMI project, IIT Gandhinagar. 3 of my books are published. My today's topic is a specific one in mathematics, volume of solids, Khatavavahara in Sanskrit text. I have chosen this to show that how the formulae for volume are evolved in Sanskrit in the earlier days, which are approximate ones and which are later on perfected by the later mathematicians. And mathematics evolved and developed in India independently without the influence of other countries. These are some of the solids, 3-dimensional solids, which are going to be discussed in this Sanskrit text. Cube, cuboid, square-based pyramid, cone, triangular prism, triangular-based pyramid, cylinder, sphere, and so on. Khata is a ditch dug on the ground. Khatavavahara is the unit dealing with the cubical measures of the ditch dug or the volume of the ditch dug. Mathematics in ancient India evolved and developed for the practical purposes, as it was necessary to calculate the cubical content of the ditch to be dug for the basement of the buildings, wells, fire altars. Fire altars are the Vedis for the sacrifices done in the Vedic ages. The excavations and cubical content of solids, that is Khatavavahara, is treated as an individual topic in the mathematical texts of ancient India. Some of the mathematics texts in Sanskrit which deal with Khatavavahara, Shulba Sutras, which are before 800 BCE, Aryabhatiya of Aryabhata, which is written in 499 CE, Brahmaspata Siddhanta of Brahmagupta, 629 CE, Trishatika of Sridhara, about 750 CE, Ganitasara Sangraha of Mahavira, about 850 CE, Leelavati of Bhaskara II, 1150 CE. These are some of the important books that I have chosen. There are many other texts which also deal with the volume of solids and excavations. Shulba Sutrakaras were familiar with the concept of volume, since they used to fix the height, the number of layers, and the total number of bricks in the fire altars of regular geometrical shape. For example, a simple construction of Smashana Chiti is explained in Baudhana Shulba Sutra as follows. Smashana Chitam Chinviteti Vigyayate Tabis Chatasrova Navava Chaturdashava Chiturupadhaya Sesham Avancha Makshnaya Apichindyat Ardhamuddharet Tasya Nityo Vibhago Yata Yoga Mishtakanam Krasa Vriddhihi. Here the shape, how, what is the dimensions, what are the dimensions, and what dimensions of bricks are to be used, how many layers are to be made, everything is specified in the Shulba Sutras. According to tradition, a fire altar in the form of a Smashana Chiti is to be constructed with the bricks 4 or 9 or 14 layers are made. When layers are considered, the concept of volume comes in. The remaining layer is diagonally cut in the downward direction and half of it removed. Its division is exact. Larger and smaller bricks are taken according as they fit. In the above paragraph, it is described that the Smashana Chiti fireplace should have a base as an isosceles trapezium. Its top surface should slope from one edge to the other, east to west. Its eastern height is up to the neck and the western height is up to the navel of the Veda Purusha. Dr. Datta gives a modern representation that this construction is based on the approximate formula for the frustum of a pyramid, namely, volume is A plus A dash by 2 multiplied by B plus B dash by 2 and that multiplied by the height, where A, B and A dash B dash are the dimensions of the lower and upper faces. This shows the fire altar in the form of a pyre. The first layer, how some isosceles, double isosceles triangular bricks are used for constructing this Smashana Chiti is shown here. This is taken from the translation of A.K. Bag. And this shows the type of bricks in the second layer, arrangement of bricks in the Smashana Chiti in the second layer. These are the type of bricks used. And Aryabhata, who belonged to Kusmapura, played an important role in shaping mathematics and scientific astronomy in India. In Aryabhatiya, the approximate volume of right pyramid is given as Urdhva Bhujatat Samvargardham Saganaha Sadashririti. Sadashri is a 6-edged solid. The volume of 6-edged solid is half of the area of the triangular base into height. This gives only the approximate volume of the pyramid. Then volume of the sphere is given as Sama Parinahasyardham Vishkambhardha Hatameva Vrittapalam Tan Nija Mulena Hatam Ghana Golapalam Niravasesham. The area of the circle is circumference by 2 and diameter by 2, which simplifies to pi r square. And the volume of the sphere is pi r square into square root of pi r square. This also gives the gross volume. Brahmagupta, the most celebrated mathematician of Ujjain, wrote Brahmasputa Siddhanta in 629 CE. He has given the accurate formula for the volume of a pyramid. Kshetrapalam Veda Gunam Samakhatapalam Kritam Tribihi Suchyaha Mukha Thala Tulya Bhujaikyani Ekagra Kritani Samarajjuhu. In this, the following formulae are given. The volume of a pit of uniform depth is area of section into depth. The volume of a solid which tapers uniformly to a point is 1/3 of the area of the base into depth. Then volume of a pyramid is 1/3 of the volume of a prism on the same base. When a pit has non-uniform depth, this is divided into parallel strips of uniform depth. The product of the breadth when divided by the sum of the widths of these strips is the Samarajju. Volume of a frustum is given by Brahmagupta. Mukhathala Yutidhala Gunitam Vedagunam Vyavaharikam Ganitam. Mukhathala Ganitaikyardham Vedagunam Syad Ganitam Autram. Autra Ganitad Vishodhya Vyavahara Palam Bhavet Tribihi Sesham Labdham Vyavahara Pale Prakshipya Bhavati Palam Sukshmam. Vyavaharika volume is, suppose A is the side of the base and B is the side of the top, then Vyavaharika volume, that is the practical one, is A plus B by 2 whole square into height. Outra volume is the gross one, which is A square plus B square by 2 into h. And the difference, so the exact volume is volume, Vyavaharika volume added to the difference of the Vyavaharika volume and Outra volume, which simplifies to h by 3 into A square plus B square plus AB. Veerasena has written a commentary called Dhavala to Sadgandagama, and in that he has quoted an old Karanagatha where he has given the volume of trapezoidal solid. plus Mukhatala Samasardham Utsedagunam Cha Vedena Ghana Ganitam Janiyat Vetrasana Samstite Kshetre. Volume of a trapezoidal solid is half of the base plus base into height. This is the area of the base into depth. The volume of the frustum of a cone is given by pi into height by 4 into 1/3 of a square minus ab plus b square, where a and b are the sides of the top and the bottom. This is done by the method of infinite division. Sridhara of 8th century has given an expression for the volume of a frustum of a cone. Mukhatala tadyoganam vargaike kritehe padam dashagunayaha vedagunam chaturanvita vimshati bhaktam palam kupe. This is better approximate formula for the frustum. This gives the volume as pi h by 24 into square root of a square plus b square plus a plus b whole square, and taking root 10 as pi, where the frustum, for the frustum h is the height and a and b are the diameters of the top and the base. Then Sridhara's formula for the volume of a sphere is Gola Vyasa Ghanardham Swashtadasha Bhaga Samyutam Ganitam. Volume of a sphere is dq by 2 plus dq by 2 into 18, which simplifies to 19 by 36 into dq. Then Mahaviracharya is a Digambara Jain who lived during the reign of King Amogavarsha, and he wrote Ganita Sara Sangraha in 850 AD. He gives a rule for arriving at the cubical contents of excavations. Kshetrapalam Vedagunam Samakhate Vyavaharikam Ganitam Mukhatala Yuti Dhala Mata Satsankyaptam Syat Samikaranam. The approximate measure of the cubical contents in a regular excavation is equal to the product of the area of the base and depth. This is the basic formula. Then the excavation is not uniform. It is separated into several units. The sums of the average of top and bottom dimensions are half. Then their sum is divided by the number of the said halved quantities. Such is the process of arriving at the average equivalent volume. And he gives a frustum of the solid in 3.5 verses. The modern interpretation of the rules is given by Professor R.C. Gupta. According to him, this rule is a sort of generalization of a similar rule given by Brahmagupta. The rule is expressed here in mathematical symbols. Let the number of sections considered be n, and f of a, b, c denote the area of a section as a function of its defining linear dimensions a, b, c. Let a1, b1, c1, a2, b2, c2, etc. up to a n, b, and cn be these linear dimensions or sides of the n sections. Then the Karmantika, that is the practical volume, is given by k equal to h is height into f of a bar, b bar, c bar, etc. And a bar is a1 plus a2 up to an divided by n. The Aundra or the gross volume is depth into a1 plus a2 plus an divided by n, where a1 is f of a1, b1, c1, etc. are the areas of n sections. Then according to the above rule, the accurate volume is given as the Karmantika Pala plus the difference of Karmantika Pala and Aundra Pala divided by 3. This is simplified to 2k plus a divided by 3. So we should remember these formulae are given in 850 CE, long before they were given in the Western countries. Here, exact volume of the solid is obtained when the sections are circles, squares, etc. The corresponding sides in the various sections being parallel to each other in all the polyhedrons. If we consider only the two extreme sections, the top and the base, then n will be the 2, and the rule is same as that given by Brahmagupta. Mahavira gives a rule for arriving at the value of a cubical content of an excavation, having in the middle a tapering projection. Parikha mukhena sahito vishkambas tribuja vrittayos trigunat ayamas chaturashre chaturguno vyasa sangunidaha suchi mukavad vedhe parikha madhyetu parikardham mukha samhita matho karanam pragvathala suchi vedhe cha. If D is the measure of side of the central figure, B is the breadth and H is the depth of the ditch. Then length of the equilateral triangular ditch, that is the kata, is D plus B into 3. When the ditch is tapering to a point at the bottom or top, Karmantika Pala is D plus B by 2 into 3 into B by 2. And Aundra Pala is D plus B into 3 into B by 2. Sukshma Pala is somewhat accurate volume, is K plus A minus K by 3. That is Karmantika Pala plus the difference of Karmantika and Aundra divided by 3. And the cubical content is this Sukshma Pala multiplied by depth. Mahavira's rule for arriving at the volume of a sphere, Vyasardha Ghanardha Guna Navagola Vyavaharikam Ganitam Tad Dashamamsham Navagunam Asesha Sukshmam Palam Bhavati. So he himself gives an Vyavaharika Palam and Sukshma Palam. One is for practical purposes, one is for more accuracy. So he has given two formulae. One gives us 9 by 2 into r cube. The second one is 9 by 2 r cubed into 9 by 10. The Bhujakriti Dhala Ghana, this is for volume of a triangular pyramid. Bhujakriti Dhala Ghana Guna Dasha Pada Nava Krit Vyavaharikam Ganitam. Trigunam Dashapada Bhaktam Shringhataka Sukshma Ghana Ganitam. The volume of a triangular pyramid is a cubed into root 2 divided by 12. And we see more and more accurate formulae were evolving. And at the time of Bhaskaracharya II, who wrote his Leelavati in 1150 AD, he has perfected almost all the formulae for volume. The greatest name in the history of ancient and medieval astronomy and mathematics is that of Bhaskaracharya II. His Siddhanta Siromani was very famous, and he has perfected the formulae given by the ancestors in his Leelavati. He gives the volume of an irregular solid, Ganayitva Vistaram Bahushu Sthaneshu Tadyudir Bhajya Tanaka Mitya Samamitirevam Dhargyecha Vedecha Kshetrapalam Vedagunam Khate Ganahasta Sankhyasyat. In an irregular ditch, measure the breadth at various points, add them and divide by the number of points. If it is an irregular solid, then measure the breadth at different points and add and divide by the number of points taken. This is the average breadth. Similarly, calculate the average length and breadth. The product of the three averages will give the volume. Here comes in the statistics. The average and mean, these are the present topics in statistics, and our mathematicians handle them very conveniently and easily. To find the volume of a pyramid and its frustum, Leelavati gives a rule. Mukhaja, Talaja, Tadyutija, Kshetra Palaikyam, Kritam Shadbihi. Kshetra Palam Samamevam, Vedahatam, Ghana Palam Spashtam. Samakata Palatrayamshaha, Suchi Kate Palam Bhavati. This gives out the formula. Volume is the height by 6 into AB plus CD plus A plus C into B plus D. AB are the measures of one face and CD are the measures of the other face. That is the top and the bottom. Buddhivilasini, a commentary written by Ganesha Devagya on Leelavati, gives an upapatti. Upapatti is an Indian way of proof for the above rule using the example in Leelavati. Mukhe dasha dvadasha hastatulyam vistara dairyam tu tale tadardham yasya sake sapta karascha vedaha khata sankhya pada tatra vapyam. So mukhe, on the face, it is dasha and dvadasha, 10 by 12 cubits. And vistara dairyam tu tale tadardham, half of that in the tale, base. So 5 into 6 are the measures at the base. And sake sapta karascha vedaha, the height is sapta, 7. So find out the volume of this solid. For this, Ganesha Devagya gives an explanation and interpretation using the example. He says that this is the tank or the three-dimensional solid for which the volume is to be found out. And here he suggests that you divide them into several uniform solids. and find out the volume of each. Then you add them to get the volume of the whole. He says first, this is 5 into 6 base. On this base, first take a cuboid, 5 into 6 by 7. And then on the 4 sides, that can be divided into triangular pyramids, 2 on the base of 5 and 2 on the base of 6. 4 triangular pyramids. Triangular pyramids are these, and these are the vertical cross section. And again 4 square pyramids on the corners. This is a square pyramid, 4 square pyramid in the corner. According to the measure given in the example, these are taken. So this is a cross section for this. So these are the vertical cross sections as seen from the top. Is given in the commentary. So today's engineering drawing, these are called plane and elevation. Finding the vertical cross section and horizontal cross section, they are named as the plane and elevation engineering drawing. This is done in the 15th century itself by Ganesha Devagya. So now they are here we have one cuboidal solid 5 into 6 into 7. Then next is 2 triangular pyramids on base 5. So that volume is 7 is the height for all. So 7 into 5 by 2 into 12 minus 6 by 2. That is the volume of each of this. There are 2 like this, and similarly 2 like this, and 4 square pyramids on the corners, which are having the volume 7 by 3 into 12 minus 6 by 2 and 10 minus 5 by 2. So finding the volume of each of them separately and adding them gives the volume of the whole solid. So this is just the explanation which I told you. In the middle, there is a samakhata, that is a cuboid with the volume 5 into 6 into 7. Then 2 suchikatas, the 2 triangular prisms of side 5, their volume is 2 into 7 into 5 by 2 into 12 minus 5 by 6 by 2. And the other one, you have 2 triangular prisms on the base 6. So this has the volume of this. And then 4 triangular pyramid, rectangular pyramid. So base rectangle means it is a rectangular pyramid. So which this has the volume of this. So adding all these volumes, we get the total volume of the solid. And this is expressed in symbols. So volume of the rectangular box is A into B into H. Volume of the 4 triangular prisms is this, and 4 rectangular pyramids are this. And adding all this, we get the formula given in the verse. So H by 6 into AB plus CD plus A plus C into B plus C. These are given in the form of verse, and that is retraced in the symbolic form. Then volume of the required tank in the example, substitute the values of the top and the bottom and the height. So this gives the volume. So as I told you, this method is called plan and elevation in the modern engineering. To find the volume of a ditch with square or circular base, it's given as Ucharayena Gunitam Chitehe Kila Kshetra Sambhavapalam Ganam Bhavet. So area of the base into height gives the volume of the cylinder or a cuboid. So volume of the cylinder is pi r square into h. So to find the volume of the heap of a grain, that is in the volume of a cone, is Bhavati Paridhi Sashte Vargite Veda Nigne Gana Ghanita Karaha Sir Magadastascha Karyaha. So volume of a cone is height into circumference by 6 into whole square. Substituting for the circumference and pi r, 2 pi r, etc., we get the formula 1 by 3 pi r square h, which is also used at present. So you rule to find the volume of a sphere. Gola Saivam Tadapicha Palam Prishtajam Vyasanagnam Shadbhir Bhaktam Bhavati Niyatam Gola Garbhe Ganagyam. The volume of a sphere is given by that first surface area gives as 4 into circumference into d by 4. Then circumference, surface area of the sphere into d by 6 gives the volume of the sphere. When we substitute C 2 by r and for d 2r, it gives the formula 4 by 3 pi r cube, which are currently used. Bhaskara has given perfect formulae for all the volume of the solids. And Ganesha Devagya gives an upapatti for finding the volume of the sphere. Earlier to this verse, Bhaskara has given the surface area of the sphere is 4 pi r square. And Ganesha Devagya suggests to divide the surface area into unit squares. That is a square with the area 1 square unit. So there will be 4 pi r square units on the surface. And then corresponding to each square unit, you construct a SOLIDS-KHATA which goes up to the center. Therefore, the height of the SOLIDS-KHATA is the radius d by 2. So the volume of one needle-shaped section, SOLIDS-KHATA is needle-shaped section, is base area into depth into 1 by 3. So it is 1 unit square into d by 2 into 1 by 3. For 4 pi r square SOLIDS-KHATAs, the volume will be 4 pi r square into d by 6, which simplifies to 4 pi r cube into 3. 4 by 3 pi r cube, cubic units. Here the sphere is divided into unit square, small units, and then the volume of each small unit is found out, and it is, all the unit is added to find the volume. Here we see the rudiments of calculus. Yukti Bhasha of Jeshtadeva, 16th century, derives the expression for the formula for the volume of a sphere with the help of the methods of calculus. This was rediscovered in Europe later by Newton and Leibniz in 17th and 18th century. The derivation of volume of a sphere as in Ganita Yukti Bhasha. Let R be the radius of the sphere and C the circumference of the great circle. Then the area of the circle is half into circumference into R. This is same as the formula given by Bhaskaracharya. The half card, see, then the sphere is to be divided into uniform slices, several slices, cut into several slices of uniform depth. So the half card BJ is the radius of the jth slice. The corresponding circumference is C by R into BJ. And then from this formula, we get the area of the circular slice as half into C by R into BJ square. Then if delta is the thickness of each slice, then the volume of jth slice is half into C by R into BJ square into delta. So the volume of the slice, when considered squares of R sin square, R sin BJ square, then volume is half into C by R into B1 square plus B2 square, etc. up to Bn square into delta. Here, so the BJ is the radius of this jth slice, and here AP into PB, AP equal to PB is BJ, and this is jth slice, and you have starting from N. The BJ square from the formula of Aryabhatiya Ganita rule 17. So BJ is BJ square is AP into PB, that equal to NP into SP. This NP and into SP can be rewritten as half of NP plus SP whole square minus NP square plus SP square. So NP plus SP is nothing but 2R. So it is 2R whole square minus NP square plus SP square. If delta, the thickness is taken to be 2R by N because there are N slices, with the thickness of each slice, the jth R versine is NP, which is J delta, and its complement SP is N minus J into delta. Hence, while summing up the squares of the R sin square BJ square, we both NP square and SP square add to the same result. Thus, by 2 and 3, we get the volume as such expression. For large N, the sum of the squares, Varga Sankalita, is essentially 1/3 the cube of the number of terms. Then this equation 4 reduces to volume as C by 2R and 4R cube minus 8R cube by 3. When you simplify this, we get C by 6 into D square, which is the formula given by the verse. Hence, the volume of the sphere is 1/6 of the circumference into square of the diameter, which is same as 4 by 3 pi r cube. We are using this formula even today. These are all perfected by Bhaskara in 12th century, 1150 CE. To conclude, Aryabhatta II, Nemichandra, Srimati and Narayana Pandita mostly repeat the earlier mathematicians' rules. The formula for the three-dimensional solids, such as prisms, pyramids, frustum, cone, sphere, and so on, have evolved from approximate calculations up to accurate formula, which are used even today. So I told you already how the mathematics was evolved for the practical purposes and how they were perfected from century to century. And it evolved naturally, independently, without the influence of other countries. These formulae for finding the volume are used in the construction of temples and buildings and are used by the sthapatis who follow the traditional methods. Calculating the earth from an excavation or pit that is going to be dug helps to plan the utilization of the earth or mud dug, such as to build an embankment, build a platform, fill up some other pit, or use it for other constructions. Why do we study the ancient mathematics texts in Sanskrit? The Times of India, there appeared an interview of Manjul Bhargava, who is a professor in Princeton University, USA, who was awarded the Fields Medal, the highest award in mathematics, in 2014. When asked, why is India still a middle power in mathematics despite its famed legacy? The reply that Manjul gave was, students in India should be taught about the great ancient Indian mathematicians like Panini, Pingala, Hemachandra, Aryabhatta, and Bhaskara. Their stories and works inspired me, and I think they would inspire students across India. Many of these works were written in Indian languages in beautiful poetry and contain important breakthroughs in the history of mathematics. The statement of Manjul Bhargava revealed the importance and relevance of ancient Indian mathematics texts in Sanskrit texts and how the study of these texts can create enthusiasm among young students and influence them for research. In this topic, especially the study of three-dimensional solids and the beginning of calculus and the rudiments of trigonometry are appealing to the students. Only a few books are edited and translated. If more works from the vast repository of manuscripts are edited and published, then the hidden Indian wisdom will come to light. These are some of the references. Thank you.
Dhanyavadaha. It's a very good topic and a very important topic on mathematics. Though it is just a measuring of the volume of the a foundation or so, but still the analysis that is available in various Sanskrit texts is quite exhaustive and given very well presented by Dr. Ramakalyani ji. She is from Kupuswamy Research Institute, a famous institute in Chennai, and we are blessed today to have a lecture from her, from such a great institute, from a great speaker, and giving a good account of all these things. People who have got some experience in mathematics and some knowledge can ask, participate in the discussion, raise your questions. Rupali Kavishwar, please shoot your question. Rupali ji. Rupali Kavishwar, please. Hari Om, please unmute and talk. You raised the hand.
Namaste. My question is about the Aryabhatta formula of volume of a sphere. Samaparinahasya एवं प्रकारेण सः श्लोकः भवति. तस्मिन् श्लोके आर्यभट्टः वदति निरवशेषम् इति शब्दः अस्ति तत्र. निरवशेषम्. Aryabhatta, if he is using the word niravashesha over there, then the formula should be not approximate, it should be correct formula. Because in another shloka about pi, Chaturadhikam, he had used asannam for approximation. The word asannam in approximation. So what is your opinion about this formula?
See,
Which is
when you,
given by you. This one. Niravashesham here. Yes, this one.
yes,
Tannija mulena hatam ghanagola phalam niravashesham. Here niravashesham means it is not asana. It's not approximate at all. So
see.
there is one commentary on this on Aryabhatiyam which says tat nija mulena, this samasa should be different. It is not like tat means if we are dividing this samasa as tat cha nijancha, tat mulam nija mulancha. So here nija goes to fourth root of pi. Then the formula will be 4/3 pi r cube.
So, most of the text translated as like pi r square into square root of pi r square.
Yes,
And if we take it like that,
Hmm.
if we take it like that, it is approximate only. And because now, now we know this is 4/3 pi r cube, we interpret it a different way, differently, and say Aryabhata is right. Okay.
No,
Because
but,
we
have
know
you
this
seen
formula.
any commentary on this? Have you seen any commentary on Aryabhatiya which says that
Yes,
means?
Yeah. So there is Soma Tattva commentary and Aryabhatiya Bhashya written by Bhaskara Bhaskara the one. These commentaries I have seen, they are translating like this only.
Okay.
Is it over?
Which commentary you are mentioning about?
That I'll see and let you know because I don't. Parameshwara commentary, I think.
Okay, we'll see.
From Bhandaga Institute, I had got that book, and I had written means one article on this. So this upon this Niravashesham and Asannam word. So I had written the article on these two words.
Okay.
Because Aryabhata is very appropriately using his wordings in his sutras. That's why I'm asking this question actually.
Okay. Okay.
Dhanyawad, Rupaliji.
See that.
May I have your introduction, please?
Yes.
Oh,
Namaste, sir. I'm Dr. Rupali Gavishwar. I did my PhD from Pune University in units of measurement from ancient to modern. So,
you are from Pune?
Yes, and PhD in Sanskrit, and I did my BSc and MSc in BSc in chemistry and MSc in biochemistry.
So what are you now? Are you a professor?
So now I'm teaching Sanskrit in Government College, Amravati.
Oh, great. So can you leave your details to us so that we can be in touch with you in future?
Yes, sir. Yes, definitely.
Please share your number, other things, details in the chat box, please.
I shared actually, and I was
you already shared.
in,
Okay. If you already shared, then I will add you in our group so that our group can take the knowledge you have with your post and other things in our group. So I want to build up a good group of knowledgeable people. That's why.
Yes, sir. Yes.
Thanks.
Thank you, sir.
Thank you very much. So anybody else would like to have share their discussions or give a question? Anybody else? Ramakrishna Garu?
No, I really compliment the presenter today. She has done a marvelous job. And what I understand is I think she's from Sanskrit background, but taken a lot of interest in mathematics. Am I correct, ma'am?
No, I am a graduate in mathematics. I was teaching both mathematics and Sanskrit for 20 years.
Oh, great. So you got a background in mathematics too.
Yeah.
That's great. Yeah.
So that's why I combined the both, and my PhD in Sanskrit, but the specialization is ancient Indian mathematics.
Mm.
I have quoted that Buddhi Vilasani, no? So I have
Okay,
my topic for PhD is the commentary Buddhi Vilasani on Leelavati of Bhaskara II. So Buddhi Vilasani gives a lot of proofs for the Leelavati rules. Actually, Leelavati, you have only rule and example. That's all. But for every rule, this Buddhi Vilasani of Ganesha Devagya tries to give a proof in all possible ways. Some of them are explanations, some of them are that is based on geometry, some of them based on algebraic formulae, because Bijaganitam is the same, written at the same time as Leelavati by Bhaskara. So using Bijaganita rules, he gives proof for Leelavati rules, and like that, using all types of methods of proof. So that's why we say Upapati, the Indian way of proof. So he gives proof for all the problems. So combining my knowledge in maths and Sanskrit, I have done the PhD.
excellent, madam. Actually, we
Excellent,
want
madam.
to.
Congratulations, actually.
Yeah,
Your
yeah.
paper is so good.
Yes.
Thank you.
And
No, in fact, today, you know.
I look up to that commentary also, because I
Yeah,
have
yeah.
not come
Yes.
across that Parameshwara's commentary.
Correct. correct. No,
no,
today.
I'll send it to you if you give me your email address. I'll send
Sure.
it to you, and then we'll communicate on this,
Okay,
and
sure,
we'll find
sure.
out something.
Sure. Nice.
Thank you, ma'am. Thank you.
Okay, nice.
Yeah, great. Actually, this I think we would also like to know your books. You said, published 3 numbers.
One is Ganitamrita Lahari. That I edited from 8 manuscripts, and that is published by National Mission for Manuscript. And the other one is Bharatiya Ganita Pravesha. I did it for Sanskrit Promotion Foundation. It is textbook aimed at the school students, for the middle school students. So what all syllabus they have, formulating that, and correspondingly what we have in the ancient text, we called out those things and written in English first, and then that is written in the Bharata Ganita Parampara in the name. It has come in Sanskrit also recently.
No, we'll definitely take more details on these books from you through correspondence, so that we'll be able to, take this, a lot of knowledge, across.
Yes.
And
The
today
Bharatiya Ganita Pravesha is definitely useful for the school students. It is middle school students, and the next one will come for the high school students.
Yes. And today, Sri Prabhakar Rao Garu, his objective, I feel it's very much fulfilled through the discussions, like Dr. Rupali has come forward with so many good points.
Yes,
And, I think we all working together, that will make these things, very wonderful. That is the whole objective of this entire exercise, actually.
All lectures are very interesting, and on varied subjects, we are able to learn so many other things also.
Yes. And then through these discussions, what will happen is, we will get some smaller groups, in particular areas. For example, this group, Rupali and yourself and many others, maybe into some mathematics related. Somebody else, into Vimana Shastra. Some group, something like, Khagola Shastra. Like that, we will try to get more and more subgroups actually. That is really one of the takeaways from this particular series. Yeah.
Yes.
Thank you.
Ramakrishna is our
Thank you
secretary
so much.
from Hyderabad. He's executive secretary from our Hyderabad. So we are. This initiation was done by him in this.
Thank you, sir.
Sense.
Namaskar.
And we are proceeding with that. Now I have got a question here. I got a suggestion rather. All these books we have, mathematics books, different books, trigonometry, geometry, calculus, so many mathematics textbooks are coming by Western authors. And how do we Indianize them? How do you how do you give in that is the Indian origin is there. In every book there should be a first para should be there, or first chapter should be there, which shows the Indian origin for that development of mathematics based on those things. Any effort has been done in the country to that extent?
Not much is done in the past. Now there are efforts going on.
Is KSRI looking into it and doing that?
KSRI is not doing much because only 2 of us are there in KSRI with maths basis. 2 of us are done.
But who is
with
doing
the help of Sanskrit Promotion Foundation and Samskrita Bharati, there are a few who are trained by me, and they are also along with me. And we try to, that's in the Bharatiya Ganita Pravesha itself, we have brought in all Sanskrit knowledge that is available in each topic from the ancient textbooks.
Yeah, my ambition, ma'am, that every textbook we should add an annexure to that in the beginning itself.
Yeah.
Now we cannot rewrite whole the textbook. We cannot write whole textbook now, taking a lot of time. It takes a lot of time.
Yeah.
So at least every textbook you take, say for example, analytical geometry we take the for another textbook only, but write a first chapter by indicating the roots of our that mathematics, analytical geometry in our Sanskrit text, and make a first chapter for that. So like that, every textbook in that chapter is added to the along with them. Our young students will understand what is the treasure we have now,
Yes.
and that is linked with the modern books, modern theories.
Actually, very few books are now, whatever in a manuscript form, only in the 19th, 20th century, very few books are now published. There are quite a lot of books in the manuscript form itself. That too, in astronomy, there are hundreds and thousands of books. And very few people go into manuscripts and publish them. That is a problem. There are a lot of books which, from the very few books published, we get so much knowledge. And there are unpublished books. The youngsters should come forward to that is publish the from the manuscript, publish books from the manuscripts, read them and publish it.
That will become an independent book itself. That is better.
Yeah.
That before that
From
stage,
the
sharp work is very important to bring that into light.
Yeah. Only when the full book is available, from that we can collect the matter and then bring into the small units, like that. We will try whatever is possible. We'll try.
Okay, please look into this and see that is.
It's a good suggestion. Professor Ramasubramaniam of IIT is also into this.
Okay.
Ramasubramaniam, IIT Bombay. He is also working on this for some reason. We'll do it. We'll take this suggestion and try to do this.
Anybody else? Anybody else would like to interact? Rahalad Kumar Garu, Ratnam Garu, N.V. Prasad Garu, who are all physics professors having mathematics knowledge, and others who have got mathematics knowledge, please come forward and have a discussion. It's a good topic actually.
It was very much enlightening. All the sutras in mathematics. We are reminded of our childhood days when we were learning all these in mathematics and this thing. Very, very nice and very happy to learn all this again. Thank you.
Actually, we learned it in school, but we knew that these were available in our ancient texts.
Yeah.
Right.
We are learning only the end product.
Yeah, we thought all these are given by
that
Westerners to us. All these formulae, whether it is volume of solid or anything, all these were given to us by Westerners. But we never knew that we had this treasure.
But at that time, we never had the knowledge of questioning who has written that. So now,
even if you question, nobody would have had the answer. Only they will use some Pythagoras. See, the Pythagoras theorem, we call it, it is not by Pythagoras at all. At least 200, 400 century before him, it is in Shilpa Sutras. They very clearly define the statement of what we call it as Pythagoras theorem in Bhavdayana Shilpa Sutra and other Shilpa Sutras also. But we never knew that. Even I was teaching both mathematics and Sanskrit till some 10, 12 years before. At that time also, I never knew. Even I wouldn't have told my students that is in our ancient text. Very few things I knew. After I got into this research only, I came to know all these things. Now I am trying to go and tell school by school and college by college and transmit this knowledge to the students.
Very good.
So, thank you, madam. It was very enlightening.
Thank you.
It was a
So-
pleasure listening to you.
Thank you. The topic has become very specific somewhat, but I thought how it evolved from approximate to perfection, I just wanted to show, that's why taken. If it is a general topic, probably it would have been more interesting, I think. Anyway,
It was very much interesting, madam,
thank you.
because every time we have a construction
Yes.
type of work in our houses, we have to go through all these things again.
Yes,
We're
yes,
calculating the volumes and all that.
yes, yes.
That
Prahlad
was
Kumar
good.
garu, would you like to speak?
Yeah, no, with permission of all, if you can
Prahlad
just,
Kumar Nara? Okay.
yeah, just one
Then-
line, can you tell ma'am about what is the OMI project at IIT Gandhinagar? Thank you.
Oh, it's
Very simply,
history of
briefly.
mathematics. Yeah. They have in most of the IITs, they have some Indian knowledge system projects. Kharagpur, Bombay, Gandhinagar, many of the IITs. And this is specific history of mathematics in India project. For them, again, I have taken some manuscripts of Ganitamrita, a text called Ganitamrita Kupika, and I am editing for them and translating it. That is a project I am engaged with IIT Gandhinagar.
Very nice. Actually, this all the IITs, then they are collaborating also on these.
Most of them, as far as I know, most of them. There's IIT Kharagpur, Kanpur, Bhubaneswar, Bombay, Madras. These definitely I know. They are doing projects on Indian knowledge system. They're involving the students also. They are teaching through guest lectures to these students. They have this bringing in this. Somebody is concentrating on chemistry, somebody is on architecture, some IITs on mathematics, like that. They are concentrating on one area, and they are trying to bring in Indian knowledge system into academics.
Thank you, ma'am.
धन्यवादाः इदानीम् अहम् आह्वयामि घनपाटी ब्रह्मश्री नरेन्द्र काप्रे महोदयं भवतः आशीर्वादं ददातु इति अभ्यर्थनं करोमि। नरेन्द्र काप्रे महोदय हरि ओम्।
हरि ओम नमस्ते।
one minute महोदय, 1 minute. कापरे जी महोदय अस्ति? Is there no? वैद्यविद्यार्थी कापरे महोदय? He went somewhere to student. Okay. Swamini ji, namaste.
नमस्ते।
Please, भवतः आशीर्वादं ददातु।
नमस्ते।
नमस्ते।
I'm sorry today I could not be very active with all of you for some reason, but I really enjoyed. I was hearing everything. I really enjoyed, and it's really new for me to know that how the construction work also is very well, deeply analyzed, and also the calculations of the volume. I'm really enjoyed all of them, and as it is discussed, we have to take this to our main curriculum of the engineering college. So we have to see how we can take it to the engineering college for the calculations and the construction of the buildings. So I'm very happy, and that boy Mandan also has very nicely discussed about all things. And my all blessings are with all of you. Om.
धन्यवाद, नमस्कार।
धन्यवाद, नमस्कार।
कापरे महोदय is busy with something else it seems. पुनः एकवारं पृच्छामि, कापरे महोदय भवतः अवकाशम् अस्ति वा?
లేరు, ఒకసారి ఫోన్ చేయండి మీరు మహోదయ, ఒకసారి ఆయనకి ఫోన్ చేయండి మీరు.
చూస్తున్నారు వేదాచార్య ఆయనే కాపర మహోదయ వేదాధ్యాయి ఆయనదే అది, బట్ ఈస్ నాట్ టాకింగ్. ఓకే, సో విశాలక్ష్మి గారు ఉన్నారా?
నమస్కారం.
ఉపసంహారం చేస్తారా?
చేస్తాను వెనకాల ఏదో వర్క్ అవుతుంది సౌండ్ వస్తుంది పర్వాలేదా
హలో
శాస్త్రి గారు, one minute, one minute.
నమస్కారం
శాస్త్రి గారు, would you like to speak?
అదేదో ఓకే ఐ కెన్ స్పీక్ ఓకే
Yeah, please.
అతీవ సమీచీనమాसीत् सर्वं मम वीडियो अतीव सम्यक् कार्यं न करोति किन्तु संस्कृतविषयं विज्ञानविषयं गणितविषयम् अधिकृत्य यत् इदानीं प्रस्तुतं वास्तुशास्त्रविषये च तत्र महान् प्रमोदः अत्र अतीव संशोधनं कार्यं one of the fundamental things we have got to bring in is how to say the table of mathematics, 2 1s are 2, 2 2s are 3. Atra Sanskrit Bharatya kinchit kritam asit purvam tat puah sthapaniyam sarvatra tena atra jananam abhiruchihi vardhate iti aham chintayami. Ativa samyak asit कार्यक्रमः sir. धन्यवादः.
भवतः प्रश्नः किमस्ति इति अवगतं नास्ति महोदय.
The multiplication tables he means, but actually.
Yeah, it was the multiplication tables.
Yeah, in I mentioned about Buddhavilasani. In that, in
it
the
is there.
Parikarmashtakam, when he talks about multiplication, he gives an example of a table. That is, he gives in numerical form the table. So he says, using these tables which are existing and Janaha Vadanti, he says, these tables are told by these people, and using this you can do multiplication. He gives an example of a table, how to see it. He says, is 1, 2, 3 and 2, 4, 6 and 3, 6, 9, like that he writes.
That particular table, like we teach the basic multiplication table in the schools,
Yes.
that should come in Sanskrit and that should become popular. That's all that I was trying to highlight. You see, Dvivaram, Dve, Chatvari, Dve, Trini, like that.
Yes.
If we do, there is a little problem. There must be some better solution for that. This is what I was trying to highlight.
Okay.
Thank you, Shastri garu. Thank you. Thank you, Shastri garu. Can I have an introduction, sir?
My introduction, okay.
No, where from you are speaking, and
I'm right now speaking from Bangalore.
Bangalore.
Okay.
What are you, sir?
University.
Yoga
Samskrutam University person.
Pardon, sir?
I am from Yoga Samskrutam University. My office work is in the US, but right now I am in Bangalore.
Can I share your details, sir? Phone number?
You have already got it in your this one. We have interacted. I will again share it.
Okay, sir. Thank you very much.
Thank you.
Please. Okay. Again, please share it, sir. I can link it up.
Okay.
Okay. Thank you very much, sir. Murthy garu, would you like to speak? KVRS Murthy garu. No, Pramay sir, no. Subramanya, Siva Subramanya Ayar Mahodaya, Vaktum Ichanti va? Siva Subramanya Ayar Mahodaya. Vaktum Ichanti va? Kamapi Sandesham Dadatu Ichanti va?
Namaskaram. I'm just listening. And everybody talk Ramakalyani. I'm just listening and enjoying, trying to understand things. Thank you.
So, Visalakshmi Mahodaya, Upsamaharam Karotu, Samaptam Kurmaha. Visalakshmi Mahodaya is our Vice President, Sanatan Dharmam. Veda Samskruti Vice President, Upajaksha Asti. Tam Apayami, Upsamaharam Kartum, Etat Prasanga Karyakramam. Astu.
Sabhayai Namaha. Because some work is going on backside, there is some disturbance. So just I want to conclude in 1 or 2 minutes time only.
Okay, that's good.
Today's all 3 resource persons gave wonderful lectures and presented papers showing the roots from Vedas and Vedic knowledge. Mr. Projwal Mandal, though he is a student of zoology, he presented paper on Khagola Vijnana, doing an excellent research. Really, I appreciate him very much and bless him. And I want him to do more and more research on our Vedic knowledge and this astronomy and astrology, in which he showed his enthusiasm. That is he will become an example for all youngsters, I think. Then Dr. Snehalata Pingle Madam also spoke very excellently on Bharatiya Vastu Shastranusara Gruha Nirmana, giving all very good, excellent quotations from our Vaidika Sahitya. And Dr. Ramakalyani Garu, she is also an excellent orator, having command over her subject and spoke very excellently on the Ganita Sambandha Vyasa she has chosen. So I congratulate all three excellent resource persons of today who have presented papers and also I appreciate very much the interest they have taken to show quotations from our Vedas and Vaidika Vijnana. So for that I'm very happy, and I thank our Veda Samskruti Samiti organizers and especially our Sri Akela Prabhakara Rao Garu, who is very much tired, in fact, due to his returning back to our motherland just 1 or 2 days earlier. So I thank him also very much for giving me this opportunity. Thank one and all.
Dr. Babu, our Vice President, Dr. Babu, is in charge of this whole IT section, etc. Would you like to, this arrangement of these things? Would you like to share, Babu?
Good afternoon, everybody. Thank you for this opportunity. It is a privilege and also a good opportunity for me to listen to these three specialized topics: astronomy, Vastu, and mathematics. Really good specialized topics by the authors who are both scholars in their own subject and also Sanskrit. That adds a lot of value to the forum. We are starting a 3 months certificate course on Sanatana Dharma. Some of these topics are also covered in this, like Vastu. Nevertheless, all these 3 lectures and some more can be presented as guest lectures in that particular 3 months course. So probably we will get in touch with all of you if you have time and also can spare time for us. Then we'll be grateful. It will also, we have a course on Vedic mathematics, and after that probably this will be a guest lecture that will be useful to all of us. And you see, a lot of knowledge is there in Sanskrit textbooks. So what we really going to get benefited is how much research we are doing using those textbooks. And research means innovation, finding new things. So if we can find new things, new formulae or easy formulas or easy way of doing some research, result-oriented research, if it is done and if it is published, then all the efforts which we are doing it will be worthwhile. This initiative is taken by Veda Samskruti Samiti and especially our Ramakrishna Garu. Though nowadays he is busy, and I hope he will start taking active part in this. Thank you very much once again. Thank you all for this opportunity.
So I thank Subramanian Garu also from Bombay Secretary, from Bombay from our Bombay section. Subramanian Garu ji, do you have to share? Already you interact once or twice.
Yeah, Dhanyavadaha. Namaskara.
Okay. So I thank everybody. Now we will close the session with Santi Mantram and Janagaramana. Om Sarve Bhavantu Sukhina सर्वे सन्तु निरामयाः, सर्वे भद्राणि पश्यन्तु, मा कच्चित् दुःखभाग् भवेत्। ॐ शान्ति शान्ति शान्तिः। ॐ सहना भवतु, सहनौ भुनक्तु, सह वीर्यङ्करवावहै, तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरः, गुरुः साक्षात् परं ब्रह्म, तस्मै श्री गुरवे नमः। सर्वं श्रीकृष्णार्पणमस्तु। इदं नमः जनगणमन। जनगणमन अधिनायक जय हे
भारत भाग्य विधाता, पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा। तव शुभ शुभ नामे जाहे, तव शुभ आशीष माहे, गाहे हे तव जय गाथा। जन गण गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे। जय हिंद।
जय हिंद, जय हिंद, जय श्री राम, जय श्री राम।